Hey everyone, and welcome to Visual Depicts Med. You know, here on the channel, our whole goal is to take those really dense, tricky medical topics and, well, bring them to life with animations that make everything just click. We want to make learning this stuff way more intuitive and honestly, a lot more fun. And today, we are diving deep into the brain to explore a super important spot, the fourth ventricle. All right, so here's our game plan for this tour. First, we're going to zoom out and get the lay of the land, the whole ventricular system. Then we'll get our vocabulary straight so we're all speaking the same language. From there, it's all about the anatomy of the fourth ventricle itself. We'll follow it up by tracing the flow of CSF, that crucial fluid, and finally, we'll wrap it all up with a quick quiz and recap to make sure everything really sinks in. Sound good?
Okay, first things first. Before we can really appreciate the fourth ventricle, we've got to see the bigger picture, you know? Let's see where it sits in the grand scheme of the brain's ventricular system.
So take a look at this. What you're seeing here is the entire ventricular system. It's basically a series of connected, fluid-filled spaces buried deep inside the brain. I like to think of it as the brain's internal plumbing and filtration system, all rolled into one. You've got these two big C-shaped lateral ventricles, see them? They connect to this skinny, slit-like third ventricle right in the middle. And from there, a tiny little channel leads right to our main event, the fourth ventricle, tucked right there in front of the cerebellum.
Now, the fourth ventricle isn't just randomly placed. Its location is absolutely critical. It's perfectly wedged between the cerebellum, the part that handles all our coordination and balance, and the brainstem, specifically the pons and medulla. It's this crucial crossroads, connecting the channel from above, the cerebral aqueduct, to the central canal of the spinal cord way down below. It's basically Grand Central Station for the fluid that keeps our brain healthy.
All right, hold on. Before we go any further, we need to make sure we're all on the same page with the lingo. Seriously, these anatomical terms are like our GPS for the brain. Without them, you're going to get lost. So let's just quickly nail down a few key directions. Here are the big ones. Dorsal just means towards the back. Easy to remember if you think of a shark's dorsal fin. Ventral is the opposite, towards the front or belly. Superior, well, that's up, and inferior is down. Lateral means out to the side, away from the center line, while medial or median means right in the middle. Got it? Just keep these terms in the back of your head. They're going to make everything that follows make a whole lot more sense.
Okay, time to step inside. Let's really explore the architecture of the fourth ventricle. And the easiest way to wrap your head around this space, just picture it as a room with a very specific roof and a very specific floor.
Let's start by looking up at the roof. You can see it has this really distinct kind of tent-like shape, right? That tent is made of two super thin sheets of tissue called the superior and inferior medullary vela. They basically stretch between the brainstem and the cerebellum. Oh, and see that special tissue kind of dangling from the ceiling there? That's the choroid plexus. We'll be talking a lot more about that guy in a minute.
Okay, now let's look down at the floor. Clinically, this area has a proper name, the rhomboid fossa. And no surprise, rhomboid means it's got this classic diamond shape. We're going to zoom in here because the landmarks on this floor are unbelievably important. So, the rhomboid fossa. Why the name? Well, it's all about that diamond shape. The top part of the diamond is formed by the back of the pons, and the bottom part is formed by the medulla. And what about the walls? They're defined by these huge bundles of nerve fibers called the cerebellar peduncles. Think of them as the massive cables connecting the cerebellum to the brainstem.
But this floor isn't just some flat, boring surface. Oh no, it's more like a landscape with all these subtle but really important landmarks, these little grooves and bumps. And they're not random. They actually map out where critical things, like the nuclei for our cranial nerves, are hiding just underneath. So let's point out the key features, one by one.
First up, running right down the midline, you have the median sulcus. It's the line that splits the floor into two perfectly symmetrical halves. Now look on either side of that line. See that little bulge? That's the facial colliculus, and this is a huge landmark because it's where fibers from the facial nerve loop around another nerve's nucleus. If this spot gets damaged, you're looking at some very specific kinds of facial paralysis. And finally, see those thin fibers running side to side across the floor? Those are the stria medullaris.
So, we've explored the room, the container. Now let's talk about what's inside the room. The fourth ventricle is a major stop on the highway for cerebrospinal fluid, or CSF for short. And this is where we shift from just looking at structures to seeing a living, flowing system in action.
So what is this CSF stuff anyway? Well, it's this super clear, colorless fluid that's basically an ultra-filtered version of blood plasma. It surrounds and supports the entire brain and spinal cord. And where does it come from? It's actively made by that special tissue we pointed out earlier, the choroid plexus, which you can find in all the ventricles.
And CSF has some seriously important jobs. 3 big ones. First, it's a shock absorber. It provides buoyancy, letting our heavy brain just float in the skull. This protects it from banging around. Second, it's a delivery service, transporting things like hormones around the brain. And third, it's the brain's garbage disposal system, flushing away all the metabolic waste.
This diagram here gives you a nice, clean map of the CSF's journey. You can see the arrows showing the flow, starting way up in the lateral ventricles, passing through the third, down that narrow aqueduct, and right into our fourth ventricle. But a static map doesn't really do it justice. To really get it, you've got to see it flow.
Okay, here we go. Let's watch this in motion. See the CSF being produced? It flows from the lateral ventricles into the third and then funnels down the cerebral aqueduct right into the fourth ventricle. And now this is the most critical part of the whole journey. From here, the CSF has to get out of the ventricular system and into the space surrounding the brain. And it does that through 3 tiny but absolutely vital little openings called apertures. Now, how on earth are you supposed to remember the names of these exits? Don't worry, I got you. Here's a great mnemonic. Luschka for lateral, Magendie for median. Simple, right? There are 2 lateral apertures, the foramina of Luschka, and 1 single median aperture, the foramen of Magendie. And trust me, you want to remember this. Why? Because if these tiny exits get blocked by something like a tumor or an infection, CSF can't get out. It backs up, the ventricles swell, and you get a really dangerous condition called obstructive hydrocephalus.
You know, the actual chemical makeup of CSF is also super important for doctors. When they do a spinal tap, they're analyzing this fluid, and it can tell them a ton about what's going on in the central nervous system. Normal CSF should be crystal clear. It has a specific pH, a glucose level that's about 2/3 of what's in your blood, and barely any protein or cells. If any of that is off, if it's cloudy or the protein is high or there are too many white blood cells, it can be a huge red flag for things like infection, inflammation, or even bleeding in the brain.
Whew. Okay, that was a lot of information, I know. So, how about we put that new knowledge to the test? It's time for a quick knowledge check to really lock in these concepts. Ready?
Okay, question 1. We talked about that diamond-shaped floor of the fourth ventricle. What is its specific name?
Go on, think about it for a second.
Did you get it? It's the rhomboid fossa. Nice work if you got that.
All right, number 2. Where does CSF come from? What's the name of that structure inside the ventricles that produces it? And the answer is the choroid plexus. Awesome.
Question 3. Let's talk about the exits. Name the 2 types of apertures that let CSF out of the fourth ventricle. Think about that mnemonic.
That's it. You've got the lateral apertures, the foramina of Luschka, and the single median aperture, the foramina Magendie.
Okay, next up, the roof of the fourth ventricle. We said it was like a tent, formed by the superior and inferior, what?
The correct answer is medullary vela. These are the 2 thin sheets that make up the roof.
And for our last question, what's the name of that groove that runs right down the middle of the rhomboid fossa, splitting it in half?
And the answer is the median sulcus. Excellent. You guys did great.
So let's boil this all down. What are the absolute must-know facts from today? 1. The fourth ventricle is that diamond-shaped space between the brainstem and cerebellum. 2. Its floor is the rhomboid fossa, and its roof is made of the medullary vela. 3. It is a critical highway for cerebrospinal fluid. And 4. That CSF gets out into the subarachnoid space through the foramina of Luschka and Magendie. If you remember those 4 things, you're in great shape.
And that's a wrap on our grand tour of the fourth ventricle. I really hope this helped make its structure and function a lot clearer for you. If it did, do me a favor and hit that like button. It really helps the channel. And of course, subscribe to Visual Depicts Med so you don't miss out on any more animated adventures into the amazing world of medicine. Thanks so much for watching, and I'll see you in the next one.